The next step is to complete the technical analysis, including international coordination notification, and depending on the results of that technical analysis, the application will be approved or rejected. Once the application is approved in the back office, it's transferred into the Spectrum Management Database of ICS Manager. The new station parameters appear here with the new frequencies assigned. We see the identified frequencies applied and channel separation, position and antenna. The Katrina antenna was available in the database and was attached automatically to the application. The next step, we'll look at interfering stations and complete a potential interference search. After that, the potential interference from our station is exported into HTZ for technical analysis. The technical study will include the coverage analysis of the new assignment, the automatic frequency assignment, and the coordination check procedure with border countries. Once the license application has been validated, the new station appears on the ICS Manager database and the user can start the technical process for this new request. We're currently in the ICS Manager database in a table of contents which shows Tetra stations. The new station is identified as A, B, C. Firstly, the user can check the location of the existing Tetra stations. Most of the Tetra stations are located in the east of France and are displayed in blue. If we return to the table, we can see the different technical parameters related to this network. From here, the user can look at the assigned frequencies. We can see the list here already, used in the central database. And here we have the new station. This window shows the technical parameters and the administrative information which relate to the new station. If we turn to the Frequencies tab, we can look at the available free channels. From here, we can check all available frequencies in the location of the new station. To start the technical analysis process, we select the new station. Go to Search, Potential Interference. We can then complete a search of all the potential interferers in a 50-kilometre radius of the new station. Click Search, and we have 159 potential interferences. As you can see, the new station and below that are listed the potential interferers from the existing database. If we select one of them and go to the Position tab, we can see the position and the coverage for the stations are already stored in the central database. The user can select all the scenarios, including the new station and the interferences, and export the network into HTZ Communication for further analysis. ICS Manager automatically exports the new network into HTZ Communications. HTZ Communications is the technical analysis module. As you can see, all of the stations have been exported. Here we use a cartographic map with a DTM layer and a clutter layer. We can display the cartographic layers in different ways. For example, we can display the image plus the clutter. Shown here is the whole network including the new station. The window lists all of the stations. Highlighted is in the new station. We can display the coverage for all existing networks. We will now perform the coverage calculation for the new station. We will isolate the station and perform the coverage calculation. For the coverage calculations, we will use -95 dBm for the threshold coverage. This coverage calculation will be used during the automatic frequency assignment of this station. Here we can see the coverage of the new station. We can zoom in and zoom out, and also display the profile between the transmitter and the receiver. The profile is displaying the ellipsoid over the DTM and also the attenuations from the propagation model. After the coverage calculation is completed, then we can run the automatic frequency assignment. We can go to the menu, Coverage, Network Planning, Frequency Assignment. We can then export the stations from ICS Manager, exporting all of the technical parameters, including the frequency plan used for this station. The frequency plan is also included on the technical parameters of the station. This module is dedicated to the automatic frequency assignment. From here, we will launch the automatic frequency assignment based on the frequency plan attached to the station. During the automatic frequency assignment, we can also take into account the intermodulation products for co-site interference. This module is most effective using C/I metric. The protection ratios used for TETRA are already implemented in HTZ Communications, so the protection ratios used for co-channel and adjacent channels are already implemented. We can then run an automatic frequency assignment. Once complete, a frequency assignment report is automatically displayed. As you can see, we have 0 interference. The new assigned frequencies are displayed. As you can see, a pair of frequencies because the station is using TDD mode. This is a new assigned frequency. We can now check the potential interference with bordering countries. To do that, we need to use a dedicated propagation model. We will select the dedicated propagation model for international coordination analysis, which is the ITU model 1546. We select this model and check the option Mobile. During the interference analysis, we'll assume 1% of time for the interferer. We can now start the coverage calculations and apply the maximum thresholds defined by the HTM agreement. This is about 112 dBn minus. This limit is not to be exceeded for coordination with neighbouring countries. We can now restart the calculation. We can now perform the coverage in a 50-kilometre diameter. Calculation times will depend on map data resolution and can vary from seconds to a few minutes. Now we will check the potential interference with border countries, which in this case is Germany. To do that, we go to the menu, Map, Border, Country Covered. The limit value is not to be exceeded. Now HTZ Communications checks with the neighbouring countries, and as the report shows, the limit is only exceeded in France. This means there is no risk of harmful interference with bordering countries. At this stage, no coordination is needed with neighbouring countries. We can now display the new assignment. In cases where there is interference with neighbouring countries, we can optimise the antenna pattern or the power of the station in order to avoid the risk of interference. On this menu, you have different options to be used to optimise the radiated power or to optimise the antenna pattern. As you can see, this menu includes other options for border coordination. At this stage, there is no risk of interference, and we have assigned the new frequency. We can now re-export the new assignment to ICS Manager to update the central database. In order to do this, we need to go to Menu, File, Export, Export to ICS Manager. Returning to ICS Manager, we are given the option to save station changes. Click OK. As you can see here, the new frequency has been changed. We accept the changes and apply the new modifications. We now import the new assignment and click OK. We can refresh the database. As you can see, the new station has been updated with the new frequency. Once this is complete, we can continue with administrative process such as license generation and so on.